So this will kind of be the introduction to the exporting data dialog that we have here. So if you see sort of on the top center of the toolbar, there's like this yellow canister going into a little piece of paper. I'll make my icons larger right there. Export LiDAR data. Let's open this up. And this has a ton of options. We'll spend a lot of time in this because this is where you generate all the deliverables you need. Export type, we are going to do points, LAS file. Let's go ahead and click source points. And over here, let's say we'll drop down and do your ground system. And we also want to come over here, see where we've got this synthetic column. If you double click on where that intersects ground, you can come over here and set synthetic to set and hit OK. And it should look like that. And that's just telling our filter that we're only grabbing ground with a synthetic flag to it. And if you want to, you could go ahead and save this, hit this little purple floppy disk up here, and create you a new filter called ground synthetic. So you never have to do that again. You could just grab the thing. All right, well, I'll just go ahead and hit OK on this, and just be sure that you got the double brackets right up there. And I'm going to go to next, and we're not going to mess with anything on this screen, but there's some pretty powerful options on here. You can do a cookie cut by polygon for any data set you're exporting here. So, obviously we have way more data than we intended to survey. So if you want to draw a parcel of the property and clip it out by that, so it'll be a nice pretty square rectangle, this is where you would do that. You can, if you are exporting point clouds too, you can also cut things into tiles, which I would highly recommend. So like with this first setting, it would cut them into 1,000 by 1,000 meter tiles, which would only make one tile, which isn't very useful. Let's try 100 and 100. So if I did that, it would break my data set up into 12 different files. And that's good for performance. You always want your data set tiled. Tiles generally less than 256 megabytes give the best performance. So I'm going to leave that off though. We're not going to mess with any of that today. I'm going to go to next, and this is where it specifies the output. So I'm going to come over here, and I'm going to make a new folder for this. I'm going to call it thinned median.
Should I leave it 100 and 100 or not?
You can turn that off. We don't need to do the tiling on this one. This is going to be a very small point cloud. Usually my goal with these point clouds is to get most down to like an emailable size. If you can take it from a few gigs to something you can email, then mission successful. And I'm going to make an LAS in here called a thinned median. And you can leave insert outputs to map if you want. I'm going to go ahead and hit finish and get this exporting. All right, and now I should have a new LAS in here. You can see I've got the thinned median LAS. I'm going to drag that down to the bottom. I'll set that as my active LAS. And now you can see we've got a thin data set. And if I switch this over to 10, you'll notice that it's much more reduced in resolution. And that might look a little pixelated and crappy, but for land surveyors, this is what they want. They want a thin data set. And let's actually look at the count that we have now. Remember, we started out with 20 million ground points. Let's see what we brought it down to. 7,000. And actually, let's look at this in terms of size, just to kind of get a before and after shot. So I'm going to go to flight sensor data. Where's my March training? Okay, so this is my original data set. What we started out with was 40 million points and about 2 gigabytes. And my thin medium now is 355 kilobytes. I mean, that's nothing. You could put that on a floppy disk, or you send it via Morse code or smoke signals. You know, that's almost non-existent how big that is. You know, but when you look at it on here, that's a sufficient enough elevation model for a land surveyor to work with. That's the kind of thing that they want. And you can deliver products like that in LAS, and you can also deliver them as raster DEMs or contours, and I'll show you that here in a minute. We'll try those with our other thinning methods. So I'm going to go ahead, I'm going to turn that thin median off and go back to my original LAS smooth right here. And we'll come and look at another thinning method. Okay, well, let's look at the next method then. The next method is just generating a straight grid file like I talked about earlier. And this can kind of combine into two different tasks at one time. The way that we do this, it's kind of a hackneyed primitive way of doing it, but it works, is you just export a DEM and then you re-import that DEM as a LAS file, and it's gridded. That's all there is to it. Because any raster data that you have, you know, is just it's a raster cell of whatever size you want it to be, and it's just assumed that the area of that cell is its value, but if you convert it to a point, then the centroid of that raster cell is the value. So, you know, like I said, it's kind of a hackneyed way of doing it, but it works. So let's all make sure that we're back here to the smooth data set, and that's selected as active LAS. And let's go back to this export LiDAR data right here. And this time, what we'll do is, let's go back to our source points actually, and instead of doing ground synthetic, let's just drop down again and do ground system. We want to work from all of our ground again and hit OK. And on this one, instead of export type points, we want to do surface. And surface is just another word for raster. Over here on the export format type, let's just do GeoTIFF. And this value right here, cell edge length, is another way of saying cell size or raster size or GSD, whatever term you prefer. They all mean the same thing. I'm going to change mine to 5 centimeters. Actually, no. Let's do 1 meter. So we'll do a 1 by 1 meter grid. You may also notice too that we've got different options here for different types of elevation products. So we're just going to do elevation, which is just a DEM, but we could also do a slope, aspect, hillshade, contours, which we'll get to separately. You can make an intensity map, and you can even make an RGB map that derives the RGB values of the point cloud and makes a planimetric map out of it. And there's also one for elevation difference, which is sort of a QA/QC tool. But a lot of these can be very useful. You know, if you have customers who are GIS analysts or want GIS products, then doing slope and aspect analysis can be very useful for different sciences. Okay, so if everybody's settings looks like that, let's just go to next. Again, this is where we can cookie cut and tile. No need to do that today. We'll just go to next. And on the output screen, I'm going to make a new folder, and I will just call this grid 1M, 1 meter. Go into that folder, and I will name a file grid 1 meter and save. All right, if you got all those options in, just go ahead and hit finish, and it should run it and insert it into the map for you. And your output should look something like that. That's sort of just a basic raster DEM. But what we're gonna, and this could be a product in and of itself, this DEM. Let me look at the size of that and just see what it is real quick. Just to keep a tab on how our efficiency's going. So yeah, that file's only 1.25 megabytes, still emailable, or Morse codable, whatever your delivery method of preference is. Okay, so now what we want to do is we want to re-import this as a point cloud to convert it to a grid file. And we have a very quick tool for doing that. If you just go up here to add data again, you'll notice there's a tab for DEM to LAS. So click on that tab, green plus button, and navigate to the output that we just made. Grid 1 meter. And there's some useful options here. You might want to load it as a read write or read only, depending on what you want to do. You should always pyramid LAS files when that option's available. I probably should have explained that earlier, but a pyramid is basically multiple decimated copies of a data set. So you're going to have a full resolution data set that's got, billions of points, and then it's going to make a one that's half that resolution, and then it's going to make one that's quarter of the resolution, tenth of the resolution, 1%, like a pyramid. And what pyramid is displayed is whatever scale level you're at. Remember, we zoomed in all the way and it said 100%. We zoom out all the way and it says 7%. That's what pyramiding is. There's options right here for the LAS version that you want. There are a lot of people who still request LAS version 1.2. A lot of different software and shops want that. And there's a weird thing between 1.2 and 1.4, which is the current one, where I think it's not forwards compatible, so you can't directly downgrade it. But that's another topic for another day. Just know that this option exists in there for you. I do have an option here for LAS output folder. I think I can hit my brackets here and put that in a project path, and I'll just call this grid 1 meter LAS. That'll work. If you ever see this option right here, append to compatible layers, that does exactly what it sounds like, and it can screw you up if you're not watching it. It would take this LAS data set and append it into one that already exists under a table of contents. And of course, we'll mix our stuff together and, cause a lot of confusion. So I would generally uncheck that if you ever see it. I'm just going to go ahead and hit OK and get this pulled in. And you can see now I've got a file up there. Is this the LAS? No, it's right here. So I have a file down here, DEM LAS layer. I'm going to pull this up a little bit and change it to my active point cloud. Let me turn off this raster layer so it's not covering up everything. And now, if I zoom in enough, you can see that I've got a perfectly gridded point cloud that's 1 by 1 meter, which is extremely tight. The surveyors are going to probably want something that's like 10 foot or something like that, way less. And let me come over here and check the size of that and just see what we're looking at. And the size of that one's about 1.3 megabytes, so still emailable size. In fact, yeah, let me turn on the contours while I'm sitting on this point cloud, and yeah, it's kind of harder to see, but yeah, see those are pretty smooth looking contours now, And the thing, there's a smoothing option when we get to exporting contours that will smooth them out. You don't want to go too crazy with it, but it's there. But the thinning itself is sort of a simplification of your data set. So it does have a smoothing effect in a sort of indirect way. So yeah, if you want smoother contours, thin your data set, generate contours from the thin data set, smooth them a little bit. Okay, let's see. The next topic that we can move into is looking at the model key points. That one's a little bit more interesting, and we'll continue looking at deliverables. So I'm going to switch my active LAS back to the smooth one where we started at. And this time, let's go ahead and go back to our point cloud task down here. And point cloud task manager. And add, and for task type, we want to look for the model key point filter. I'll just give this a name like training And most people use the acronym just MKP, so we'll just call it an MKP filter. This is like model key points. MKP is sort of an old industry term that used to mean something different than it does, and now it means something else. So if you hear that term getting misused, don't be surprised. Okay, I'm gonna hit OK on that. And here's our model key point page. A little bit more simpler than what we've seen recently. So on this, for source points, I'll open up my live view again, drop down a filter, and we'll just go with the ground system. Looks like I inadvertently saved mine with a model key point set. I'm just going to turn that off. So yeah, just make sure you got the ground one set and it is synthetic is set to ignore. Okay, and destination class for this one, we actually have a class specifically, class 8, reserved for model key points. We don't have to do it this way. We could, use a flag like last time, but let's just do it this way just to kind of practice how that works. So, 2 classification, class 8, reserve model key points. All right, and unit, let's just do meters, and let's just say, let's do like a 5-meter sample distance. And for maximum positive and negative deviation, let's just go with 10 centimeters, 0.1. That's probably some decent basic settings for this.
Both of them are 0.1?
Yeah. Yeah, go ahead and hit apply and execute for project. All right, mine completed. And we can actually just, before we export a product, we can actually look at the results of this, right inside what we're working with currently. Okay, I'm gonna open up my live view here and let's create a filter just for our MKP. So whatever you got, just go ahead and hit toggle all classes off and then check the class 8 reserve model key points. And I'm gonna save that as a filter. I'll just call that MKP filter maybe. Okay. And here's our model key point surface. I'm going to change this from 10 back over to point, and then I will force 100% resolution. And now you can kind of see the results of how that works. See the flat open area, how it's got everything in 5-meter intervals. But when we get to this super steep slope right here, it adds a whole bunch of points. Let me see what the count is on this. So 46,000. So we've gone from 20 million to 46,000, and keeping in mind that, like look at this drainage right here, it really preserves, the detail of that drainage, which is very important. See, that's a pretty good looking drainage there. You can see right here, it looks like I got a piece of low noise that I missed in my data set. So sometimes doing these thinned or decimated versions can kind of bring out your errors in ways like that. So it's always a good idea to look for weird anomalies like that. Okay, if everybody got up to this point, we can generate a deliverable from this. So we'll try a different one just to kind of go through all the different things. So let's go to our export wizard here. And I'll do points this time. Instead of LAS, notice that we've got different kinds of data formats. We have CAD formats, shapefile, and there's also an ASCII XYZ. ASCII XYZ is actually somewhat of a popular format because it's basically universal. You know, as long as you know what your columns are, any geospatial program could import this data and do something with it. You know, so it's a very universal format. So on this, I'm going to hit my source points again and select MKP this time.
You're going to export it as the ASCII?
Yeah. And also you can notice here that we've got different attributes that we can export. So if people are interested in, you know, the LiDAR's intensity or the number of returns and the return number, you also have red, green, and blue in here too. So if you want to retain those color images, you know, this is all of that metadata that comes with LiDAR data that, you know, can be useful to certain types of analyst classification. I mean, that's not useful because we assume this is all ground, but if you want to export a whole data set like this, you could. And you can make this comma delimited text, space delimited text, or tab delimited text. I'm going to leave it as comma. You can include the headers on there if you want to name the columns. So I'm happy with these settings. I'm going to go ahead and go to the next screen. Not cookie cutting, not tiling yet. I'm going to specify an output location. And I will just call this one MKP ASCII. I'll name it the same, MKP ASCII, and finish and export. Done. Let me check my size. So this one's a little bit bigger. It's 2.6 megabytes, but bearing in mind it still has those drainages and more intricate features retained. So that's a decent trade-off. Double size, but you got better features. You could still have discontinuities with your elevation model if your ground classification wasn't detailed enough, or if you had problems with canopy penetration, stuff like that. Really intricate civil features can have, you know, a lot of detail to them. Yeah, so the topic that we're on, you know, that pretty much covered data thinning strategies, and, you know, by necessity it already started to pour into the deliverables topic that we had to cover. So deliverables, you know, we already talked about that, raster elevation models. It is worth pointing out some of the sort of jargon associated with this. DEM usually refers to digital elevation model, which means a bare earth surface. DSM usually refers to a digital surface model, which includes all features, buildings, trees, stuff like that. Digital terrain model usually means the same thing as DEM to people. I think sometimes people might include stuff like bridges and stuff in there too. It's jargon, so the definitions differ depending on who you're talking to. There's also canopy height models, which can be raster data sets. These are typically used by biologists and forestry service people. Basically, you know, we just classified out the ground, but some people actually want to classify the very tops of the canopy and extract that as a data product. So that can be a raster in and of itself. And there can also be difference models. This could apply to you someday with volumetrics. Sometimes you'll have an elevation model of, let's say you're doing a burrow pit, right? You have an elevation model of before, an elevation model 3 months later, 6 months later, and every time you calculate a raster difference of how much volume was scooped out of that burrow pit. Or the vice versa, if you have a refuge pit where they're building up materials, you can track the elevation over time with difference models that way. So it's a good tool to know that it exists. Other raster products, I kind of already talked about slope aspect, RGB, intensity. Does anybody not understand what those are, like slope and aspect? Seems kind of self-explanatory. Okay. Point clouds, we talked about LES. We did an ASCII export, and then there's also CAD formats. One problem with CAD formats, though, is the CAD manufacturers tend to break their file formats every once in a while, you know? So you might be trying to generate a product for a guy with an old version, or you're generating a product for an older version and he's got the latest version, and you know, it can turn into a nightmare. That's why ASCII is so good, because it's universal. Contours, we're going to look at that next. That's the last deliverable. Those can be in shapefile or CAD formats. And then we have another one called point insertion. This was a recent feature that was requested to us by I think USDA or USGS, one of the federal institutions. But it can generate what's called DZ maps, or delta maps, which can generate a raster map showing the elevation difference between your flight lines. I really need to get a visualization of what that looks like to show you, but it's a way that you can QC your data set, and also institutes like the USGS that are ingesting data from other users can QC the data set that's coming in from them. Okay, so if you actually look on the data set that I sent you guys this morning, I actually did include the orthomosaic for what we flew yesterday. Let me drop that on my computer real quick. Yeah, if you look in that folder that you downloaded, there was an orthomosaic folder, and it's got an ortho on there. I'm going to go ahead and add that to this project that I'm looking at. If you want to add it and have a look, you know, you can, just like yesterday, go to Add Data and go to Raster tab and Add, and go navigate to that. So, mosaic. Yeah, so that's the orthomosaic that was generated from our flight yesterday, and depending on how we were moving around, you might even be able to see us in there. But yeah, it's a pretty good ortho. Trees look nice and crisp. The point I wanted to make, I just wanted to show you that this ortho's in there. If you want to, y'all have this license for another 2 weeks, and you got the data set, so you want to poke around, there's that. But there was one very important thing I wanted to illustrate, was that here's the DEM that I generated. You know, I told y'all yesterday that to use Metashape for EVO, you feed it a DEM from the LiDAR-derived elevation model instead of having a photogrammetry one. And you may notice something kind of wacky on this one, is that I've got building tops on there. And this is by intention. When you want to make a nice crisp orthomosaic, you want to have a bare earth DEM plus rooftops and bridge decks. Because a lot of times the way photogrammetry will stitch together an orthomosaic, you could have weird tears and stuff in your rooftops to where it didn't know how to drape the photo correctly. So I just wanted to point out that this is kind of the export that you want for an MFE. And here's what it kind of looks like in the classification view. You can just kind of see that I didn't go into a laborious detail with classifying this. I literally just used that above line classification tool and just got the rooftop. You can see I didn't even get the sides. I didn't bother with any of that, just the rooftop. And it gave me a very, very nice crisp orthomosaic. Sometimes buildings can be tricky because if you have overhangs especially if you have wall-less structures like ramadas and stuff where you're getting points underneath the ground and the roof, that stuff can get a little bit tricky. So if you have points underneath the roof and the roof itself, you may get artifacting like this. See, there's that bay door. You can see I had points underneath it and on the roof, and that's kind of the result of that. Let me see if I could draw a profile across that. And obviously, I did a crappy job, but it's also somewhat instructive. See that? So those points shot in underneath our little plastic dangly, whatever the hell you call them. So very, very important thing to keep in mind. You'll also sometimes see, let me see if I can come up here, you might see points drop in through the windows sometimes. I don't really see any today. Our flight angle must have not really caused it. But yeah, a lot of times buildings, windows, you'll see laser shots come in and they get inside the building. And if those become classified as ground, it can be problematic to your elevation model and to having a clean orthomosaic. So in this instance, I'll just show you the options that I used to run to get this orthomosaic. I just ran Metashape for EVO right here, and I selected my retained photos only. So that's the cold down, trim the fat version. And then you can see there's my DEM right there. It's auto grabbed since I had one in there. And then all you have to do is name the layer and hit submit MFE job, and that's how you generate an orthomosaic. So pretty straightforward stuff. Cleaning up that elevation model is probably the most laborious task in there, but it's worth it for a clean image. All right, let me jump back to where I was and let's go over contours real quick. I did briefly talk about like this tool right here showing contours. But let's talk about the actual official way to render them. One thing to keep in mind about this view right here, and somebody already asked me earlier, if you update your points, it'll update these contour lines. It's sort of a live view. And it's also based upon the decimated view of points that you have. So as I'm looking at it, let me actually switch back to my all points instead of the model key points. I'm going to turn off my all pyramid. Yeah, I think I froze my computer up for a second. This force 100%, very dangerous button.
Which active layer do we want to look at? The smooth?
Yeah, smooth's good. And you see I got my all points on with contours and it's trying to draw contours in the trees. So that can... Okay, all right, I'm back to where I needed to be. Okay, so to export contours, let's go back over to the export LiDAR data again. We're gonna wanna go for surface. Let's check our source points. Let's change to our ground class. So ground only. Make sure that's synthetic. You're not grabbing the synthetic one, just only ground. And on this one, I'm going to scroll down over here and select contours. I can turn off elevation. And when you click contours right here, you'll notice that there's a new tab that opens up for contours that has all the options for them. So lot of stuff to go through right here. The contour interval is obviously the most important one. That's going to be the interval of your contours. Maybe I'll set this one to, I'll just go with 5. And then contour intervals per index, index code. Contour intervals per index. So basically what this is going to do is every 5 intervals will be considered a index contour, which, you know, in this case would be 25 meters. So I don't know if y'all have ever seen like old USGS topo maps. You might see them at 10-foot intervals, and it'll be like, there'll be 3 lines that are like 10 foot, 10 foot, 10 foot, 10 foot, 50 foot. And it'll be a thicker line. And if you want to achieve that kind of visualization digitally, you're going to want to have an attribute that codes the index contour or the thick one with a different code. And in this case, it would do them every 5 contours, and it would give it an index code of 1. The intermediate contour is the non-index ones. It'll be given a code of 2. The short contour option right here, this is a way to remove like small little contour fragments that are just unnecessary. So if you have a contour that is, the perimeter of it is less than 50 meters, it will just be omitted from the data export. Otherwise you'll get, you know, what I like to call little boogers, you know, just tiny little contour that just kind of dirty up your map. Let's click on, we can click smooth contours here. Generally, the rule of thumb with this smooth contours is you don't want to make this value any more than a quarter of your contour interval. So our contour interval here is 5 meters. You know, we wouldn't want it to be more than a quarter of that. I usually keep it pretty low. If you could exaggerate your smoothing too much to the point where it, you know, you're basically muddling up or distorting your data. I might do a 0.2 or 0.3. There is an option for annotations in there. You know, if you're using a CAD format, a lot of times annotations will be, you know, with the elevation labels will be drawn directly on the lines, and that'll be visible if you pull it into CAD. I generally don't use annotations. Let the operators annotate things however they want to. They'll probably be annoyed by them, honestly. I'm going to go ahead and go to next. We're not going to cookie cut or tile here. This is actually, contours are a good situation where you might want a cookie cutter, because as contours run out to the edge of the map and run out of matches to triangulate against, they can do really squirrely things like make straight distorted lines.
One more question. If you do recommend, you want to uncheck that, right?
Yeah, I would think so. Yeah. Depends on the kind of feature. Some features could get distorted, you know, by having break lines. So just, it all depends. You know, you have to look at it on a by case scenario. Yeah. But yeah, cookie cutter could be very useful. You'll probably see pay attention to the edges of the map when we generate the contours. It can make some really distorted looking squirrely stuff that you may not want. I'm going to go ahead and go to next and make a new folder for output on this. I'll call this contours. Uh, 5 meters, I guess. I think I misspelled that. And I'll insert into map output so we can see them and execute. And executing contours can be one of the more time-intensive data outputs, because it's trying to actually, you know, trace and calculate that line all through your elevation model. And if you have a very dense point cloud like what we got here, 20 million points, that's a lot of points for it to spider through and figure out how to draw the lines. But while we're waiting on that, let me just finish up the last few slides I got. This is all some slightly more exciting and very useful information. So the first one that I'd like to point out is what we call EVO Explorer, and this is a free version of EVO that you can distribute to your clients, and they can also receive data sets from you in those Explorer packages. So if you have a client that you frequently give data to, they can download EVO like we're working on right now, same program, it's just a read-only version. You can make a map package that you can, or an Explorer package that you can send to them with all your data in it, colorized point clouds, photos. Remember that photo inspection tool that I showed y'all earlier? Like here's an example of it on the screen. You can give that to your clients. So that's a major boon to yourself, something to give to your clients. We've had a few clients of our customers that use these, and they love it. They expect it now, so that's a dangerous one to go into too. They're going to expect it from you, but it's good to know. You could also use it for your own employees. If you got a manager or somebody that you just want to inspect your data for you, you could hand it to them that way, and they could overlook things and help you out, or trainees or something. Another feature that I want to talk about was features that we have with Reckon, our cloud service. So Reckon does have the ability to publish geospatial data like rasters. This example is showing some stockpiles with some hill shading. And this is just an online GIS system. So without anybody needing to download any fancy programs or download any data, you just send them a link to your data and they can review it this way directly in a web browser. So you can upload everything to that: rasters, point clouds, vector files, stockpile numbers, contours, everything. It also has the ability to auto-generate reports and tables. So for example, like this stockpile yard that we're looking at right here, you can see there's little labels on there that have volumetrics for it. So you can just, there's a button that you can press to print report, and your client can get a monthly report of what the stockpiles are for that site. Reckon can also be used for cloud archiving. So if you don't want to deal with data management with a bunch of external hard drives and network access servers, you can use the cloud as a storage for all your flight cycles. You can also upload those Explorer packages to it. So if a customer has one of those EVO Explorer licenses, they can download the packages from Reckon. And Reckon is also what you used when you downloaded the EVO that you're using right now. And you can always access the latest version of the software updates, manuals, and firmwares via Reckon as well. So a lot of good features on there, and even if you're not interested in the paid services, the free stuff that comes with the sensors is very useful. And I also wanted to talk about support. As a company, we really try to pride ourselves in support. We think that kind of gives us the edge over other people, because the complexity of these sensors and data and software that you use, it's like you can't just chunk somebody a bunch of hardware and software and just be like, all right, you're good, go for it. You have to maintain a relationship with people and work with them and train them and support them when they hit snags. So we have a ton of resources to do that. We have a searchable knowledge base that all of the tickets and big topics that customers come to us with, we try to put those into articles that can be looked up and referenced. We also do the free training every month. This is the in-person free training. We do this every month. So if you get a new employee or somebody who needs to come in, they can come in and get this training. There's also a monthly webinar version for it too. So if you can't make it to it, or if you got a new employee, then they can go to the webinar training. We have a support ticket system. If you just send an email to support@geocue.com, we try to respond within 4 business hours for all support tickets. That's our goal for that. We also accept phone calls. If you get stuck in the field, something's wrong with your sensor, something that you don't understand, just give us a call. We'll take in-field calls to help you get out of a bind that way. If you ever do have a support question, the way to get the fastest resolution for that is to send us as much information as possible. Send us screenshots of the errors, send us error logs, send us photos, send us a detailed description of what you were doing before, during, and after the problem happened. The more information you get to me, and I'm one of the ones that primarily handles support. So if you send me a ticket, more than half the time you'll get me. And if I got more information, I might be able to respond to you and get you unjammed real quick. We also do extra training, like you were asking about with brake lines. Extra training is a paid service, but if you do have advanced topics that you want to cover, we do in-person training. We visit people on site, or we can do like a webinar-based training via Teams, whatever accommodates you. And we also do that for in-field stuff like demonstrations, remedial training, or even just support assistance. I go out to the field all the time. I get calls from customers saying, hey, how do I do this? Can I get some extra training on this? Whatever. We do in-field work as well. And we also do consultancy if you want. I've never dealt with that personally, but if you want some consultancy about how to how to establish a business or division for drone mapping and scale it up, you know, we have people with a lot of experience in that can help you in that regard. So contact us for consultancy. Yeah, there's my contours. Those were 2 meter contours. You can see sort of that weird edge effect there where it ran out of places to go and it kind of interpolated back to the next area. So you do want to trim this, cookie cut this stuff out if you actually have a deliverable product to a customer, but that's a very easy thing to do, and that's what the output looks like. Those are pretty smooth looking to me. I think those are acceptable for most people. Okay, well that's all the material that I had for the 2 days. We've blasted through everything and got it cleared up. So, you know, open floor now. If y'all want to go back to any certain topics or anything special, let me know.
Show how the EVO Explorer works. You have a sample?
Yeah, let's do that. Good idea. I'll show you both. Just to revisit this Image Explorer thing, on the left toolbar, Show Image Explorer. If you click on that, your cursor turns into a little info tool, and you can just click on something. And that's a lot of people who do power line inspections are starting to find this tool very useful, because you can click on electrical infrastructure and get multiple views of it. Let me see if I can actually zoom in and hit like a transformer or something. So here's a light pole. Yeah, see that? Mm-hmm. See, I've got multiple views of that power transformer. So that's good for inspection, or like what we saw earlier with just trying to identify a ground feature and figure out what it is, like these ballards here, you know.
How do you choose how many images are you seeing here?
There is, over here on the right corner, there's a option.
Mm-hmm. Oh, okay.
And you can have max images. It goes I had mine up to 50, but you know, something smaller is usually a better thing to do. So that's how you look at the Image Explorer. And to make an Explorer package, what we're going to do is come over here to the Project Manager, and you need to outline the files that you want to add. So let's just say I wanted to add contours, retained photos, our smoothed LAS, and we'll just leave it at that. That's all we need to do this. LAS, our retained photos, so that we have a reference back to those images. And it'll also include those images too. If I grab one of these retained photos, it will also add the photos to the Explorer package. So this button right over here, export or publish Explorer package, this first option right here will export it into a local directory. So let me just make one called Explorer package. So that'll be saved to my computer. If you didn't want to publish it to Reckon, you could do the same thing here. Just click that, select the company that you want to upload it to, and give a name and a location. I won't do that for now. And let me hit export. And the best thing about this is when you look at the directory structure of an EVO project or any sort of geospatial program, it's going to be just a whole rat's nest of different files scattered all around the place, but this will package everything into one nice tight single file. So it's a very good way to transport data. I even use it to transport data between workstations for myself. So if I want to take something to another workstation, I'll put it in an Explorer package and drop it on a network share or USB drive or something. So this will just take a minute. It's trying to compress all those photos in the point cloud and, you know, smash everything together. So when this finishes, I'll show you how to open it. There we go, finished. And, you know, if you had a client who wanted to use this, you know, what they would do is just grab this Explorer pack, you know, they would get a license string like what we have here, and then just grab the Explorer one right here, And let me just do a new project.
Oh, okay, so they need to install the EVO and then put this license.
Yeah,
Okay.
yeah, they got to have Explorer license to use it. So what you'll do after that is go to File,
And all customers that are buying the sensor, they have this client license.
yes, correct, yeah. Yeah, and if you want a separate string, if a customer wants a separate string to give to a client, I think you could just contact us and we can make them their own string. So if I go to File, Open, Explorer Package, this is going to ask me to select that Explorer package. You can see it there. It came out to be about 2.4 gigabytes. So considering all the images and point cloud it has in there, that's a pretty good size actually. And then you need to specify an output location to where it's going to unpack all that into. I'm going to make a new folder called Explorer Import in here. And import that, and it will.
So you will need to send this packet to the customer, or it's something that can be in Raccoon and you will directly be able to visualize the document that we
They need to get a hold of that package either directly or through Reckon or some other means.
So
Yeah.
it's not something that we can keep on the cloud and they will go and they just.
I don't know. That's a good question. Yeah, I don't know if you can retrieve Explorer packages directly through Reckon through EVO. That seems like a feature we should have, and maybe it does exist already, and I'm just not aware of it. Let me see. It's not in there. Yeah, I'll have to ask about that and see. That's a good question.
Is it possible to get that this image explorer?
I think, I'm sorry, I'm confused. Say that again?
Could we grab this section that you just did on image explorer
Retrieve
and
an-
give it to Brett like you did the other ones? Is that possible?
This section, this section specifically?
Yeah.
It's gonna be a little bit harder to cut it out of the larger, because these are continuously recording cameras.
Okay,
no problem.
Yeah.
Gotcha.
Okay, so here's the Explorer package that I imported, and hopefully I'm not going to put my foot in my mouth. And yeah, there we go. So you can see that the Image Explorer works through this, and I am on the read-only version. And
You basically have all the tools. You just cannot process anything.
exactly, yeah. You can't do any alterations or exports of the data. It's purely view only. But you know, that's a very useful thing to have still. All right, well, I wish I had more for everybody, but that's it. So we can wrap it up for the day. Yeah, y'all are a pretty smooth crowd. Usually I got a lot more moving around and hands-on to do, but you guys pushed through it pretty good.